Welcome to our next highlight here on Industry Stage in Hall 11 D72. Here on the panel, Design for Additive Manufacturing, unleashing the power of AM throughout design. Yeah, today we want to bring together experts from various industries to explore what it truly takes to design effectively for additive manufacturing. Our discussion will delve into key aspects like selecting the right materials or geometric freedom or utilizing the advanced software. And we want to talk about AI, and I think some more topics will come. And so I'm very happy to welcome following selected experts here on stage. Please join me in welcoming Eva Maria Dyson.
Hello.
Eva Maria is expert for professional industry and product design and head of Association of German Industry Designer in Southwest Germany, right?
Yes, exactly.
Good to have you here, Maria.
Thank you.
Tim Grotjan, some of you already met him this morning because he had a presentation here. Tim Grotjan is founder, director, CEO and chief product developer of Z. It's a bicycle development company based in the Netherlands. And he has more than 8 years of experience as product developer, working with various companies throughout the world. Good to have you here, Tim.
Yes, thank you.
Thank you for joining us. And John McElhenney. John is with the Stratasys board of directors and co-founders of former CEO of Onshape, acquired by PTC, and there were several more. It would take a long time to name all the list.
It just means I'm older, that's all.
Yeah, but that's very good to have you here, John. You are based in Massachusetts.
Boston.
In Boston, and we are very happy to have you because you have this broad overview about so many different companies and so much experience in the industry.
Thank you.
Before we start, we want to show you three and the audience something. You know, we asked the visitors, what does design for AM mean to them? So, do they have an opinion? And what is the game here? And let's have a look.
In AM, you design first the holes and then the materials around the holes. You have to rethink it. You have the opportunity to have new freedom. You can make everything. And in standard design, you have to think, oh, how can I drill it? How can I mill it? Or something like that. So in AM, you do it.
Could you get everything you said?
Yes.
You have to first design the hole. That's nice, isn't it? Eva Maria, is it so simple?
No, it's not simple at all. But it had quite an impact over the last 15, 20 years, of course. I remember when I was a student, we had to build the same product twice. One for the traditional manufacturing and one for the AM way. And that's, as a student, that was really exciting because you could find out about new forms. You used to design in the computer and everything. And now you see it getting implemented into the industry more and more, and not only in prototyping, also in serial production. And that is really cool to see.
Tim, from your perspective, did you start with thinking about a hole when you were thinking about bicycles?
I don't think it's from a whole, but it's designing in 3D already and engineering. So it's starting to design with the 3D software, and there you can really shape different ways than when you would be able to do with just a pen and a paper often. So that's how I do it. And also then very quickly when you have the 3D model, you can print it and you can have something in your hands. And that's for me, it's the most valuable part as well.
So for you, it's the first step in from the idea to getting the prototype in your hands. That is important, and then you move on and shaping that still.
Yes.
And for you, the whole was it start when you worked in the several
I feel like
software companies?
I feel like I've been in this industry long enough to say that the whole was actually the invention of the wheel. But when I think about innovation and about design, starting at the end, of course, is important. You know, what is the function? What is the thing that you're actually trying to create? I think what additive has done, and as well as design tools and simulation tools, is it's allowed you to go down a path and be able to quickly pivot and adjust based upon things that you find out and learn.
That's what Tim meant.
Yeah,
right?
but different than just iterating just an initial prototype. I mean that the combination of tools, both from computation and visual simulation, physical prototyping, new materials development, new suppliers that become available, and often what happens is you get locked into a design and your ability to then shift is very difficult. And I think the tools that are available today, both additive, both for prototyping and manufacturing itself, but also the design tools, make the cost for changing actually not as great as it has been in the past. So I think the idea that designs get locked down so early in the process, it actually extends further into the design cycle to allow you to start getting feedback, which is actually, in the software world, a critical philosophy about making rapid changes, is you allow a sort of an agile design process. And the tools are now allowing that in an agile hardware design process that allows you to iterate with more customer feedback earlier in the process.
Mm-hmm. And when you think about the customers, they do not the same survey like you just mentioned. So they come with a problem. But how to bring these worlds together? Maybe Eva Maria, when the customer comes and says, I need a solution, what is the starting point then for you?
First of all, you have to look into it. And really every new design process comes with new challenges. So when you start, you ask the client what he wants, what the user needs and stuff like this. And so you start working and developing concepts. And then after a while, you maybe get to the point where you think, ooh, this part or product would perfectly fit to the way of additive manufacturing. Because AM is it is another tool for the designer. It's not replacing other technologies yet. And then you speak to the client and you work something out with the engineers and everything's fine. But sometimes...
But there might be the first gap in my perspective. When somebody comes with a problem that shouldn't be necessarily a 3D printed solution. Mm-hmm. So how do you solve this first step?
Yeah, you're right. Normally there's not a specific fact that tells you at the beginning that this product is going to build for AM specifically. So you have to start working this out. And then you have an idea, and then you start talking to the engineers. And normally, everything works really good when you put all the disciplines together. A designer alone cannot do this job.
And that's a case in your company, that you have all the different people together with the different approaches to a problem.
Yes, exactly. And also, it's really important as a designer to be aware of all of the different manufacturing methods. Like her and me, we both study industrial design. And then you really learn a lot more about which manufacturing methods you can choose. So you can choose CNC, or you can choose like a molding, or you can choose additive manufacturing. And you pick the best solution for each project. And that's really what I like about being an industrial designer instead of just like a visual designer, where you would only focus on the shape of a product. But for us, it's really important that whichever project we have the knowledge which manufacturing methods we can choose from. So that is correct.
John, how does the software support this process when somebody comes with a problem into an office and says, okay, I need more strength in a connection or something? How does software, today's software, focus on this problem? I
think one of the key drivers in design, whether it be something that's a physical product or whether it be a software product, is how do you get the end concept or some concept as quickly as possible to the appropriate people so that you can start to iterate. Let me give you an example. So in our application, it runs on your iPhone, it runs on an iPad, it runs on any kind of a web browser, PC, laptop, whatever. When we were building our mobile application, okay, a design solution, we were building our mobile application, Anybody want to guess how much code we wrote before we tested it with a person? 0. 0 lines of code. What we did is we took our current web browser-based product, cut out a bunch of the icons, put a camera, and then we had people in another room watching, and we asked them to do some things. We said, you know, draw a box. And we watched them literally move pieces of paper around the different icons to understand how they were thinking. And the reason we did that was we wanted as quickly as possible to get some feedback so we could iterate without costing so much that we got fixated on a path. And I think the same thing here is happening, that you're seeing tools that allow for rapid communication and keeping the investment to get feedback to iterate very low. So the tools like additive manufacturing, tools like Onshape, tools like, you know, quite frankly, Zoom, you know, communication tools that allow people to get further in the process earlier. It allows you to truncate certain paths and don't go down that path and then iterate from there. And then, of course, once you can get a prototype, once you can get early manufacturing sort of in the process, then it allows you to do things that may not have been possible with some of those concepts. And again, the whole idea is making the cost to pivot and change and adapt relatively small so that ultimately, you know, you're building ultimately what a customer or consumer wants. And that's the key, is the quicker you can get it to the people who are actually you're trying to build it for or design for, the quicker you can get that into the product, the more chances you have to iterate and therefore get the right product for that customer.
But how to get the problems or the limitations of additive to the customers? So they now let's think about we have them on the track. They are open for a subtractive, for additive, for any manufacturing method. They don't focus too much on the outer shape. They are happy, but they do not know about the limitations. So they come and use your software or come with an idea how to bring, you know, what is good, or where is additive sufficient, and where are the limits.
Sure. Well, it turns out that, you know, there's a lot of knowledge that's out there already. Service bureaus tend to be a great place that you can work with because they deal with clients from a wide range of different manufacturing techniques and products. So that's a first place I would be looking for. Secondly, what's amazing to me is online communities of being able to ask people questions. You don't necessarily have to put your proprietary design out, but you can put some of the trade-offs out there, and you'd be amazed at how vibrant many of these communities are, where you'll get responses back within 20 minutes. I will tell you an interesting story. One guy was writing software, and he asked somebody, sort of said, can somebody help me write a macro to do this? It's an interesting question. And it was Cricketville. Nobody responded. And so he went and sort of said, I wrote this macro that does this. What do you guys think? And immediately everybody said, no, you're doing it wrong. You got to do it like this. You got to do it like this. And half the macro was written for him because people wanted to prove what they knew. So communities are vibrant, and I'd say tap into those to at least try to get, as we would say in the US in a baseball parlance, to get in right field, center field, or left field to kind of understand that where you're in the range, and then you can deal with experts to weigh the trade-offs.
Eva Marie, in your perspective, what are the limitations, and how do you talk with your customers about these?
It's difficult because sometimes the knowledge gap is too big. Because, like you said, sometimes you have clients that are never had some point where they realized what AM can do.
Have you an example for this?
That's a good question. Maybe, yeah, gute Frage.
So somebody came to your office and was totally out of track?
No, you have to explain to the people, as an industrial designer, you don't have a specific industry you work with. You have the automotive industry, I told them I did a harvester once, then you have chairs, kitchen machines, so everything. And they all have another production line. And sometimes when it fits and you work with AM, you tell the customers, look what we can do, and then you start printing out prototypes, you show them, and sometimes they say, wow, what's this? How do you get this? It's not.
But how mature is additive in that aspect? When the customer, I still want to understand the the limitations and boundaries when somebody comes, or even, or on the other hand, the possibilities?
If you have an experienced customer and they know all the possibilities, then it's very easy to work with him. But sometimes you have to start explaining at the beginning, and then it's really hard because they first find out they could do metal, and then their whole world is exploding, and then they start generating new ideas, and that could sometimes generate a process that's never ending, and that is the real difficulty sometimes.
Let me ask a question a different way, that it makes it a bit clearer. Do the customers come to you because you are an additive expert?
No.
That's
That's
maybe that's
easy,
a
easy
question.
answer. No.
Yeah, and
They come for design impulses.
okay, and what is the point when you say, okay, this design impulse will be an additive solution? How are the steps to when you come to the additive solutions?
You work together with the engineers, because then you could have a 3D model in the computer, and then you start taking a look into it, and then there are more and more functions that will go into it. Because with the additive manufacturing, you can put more functions in one model than with the normal ones sometimes, and yeah.
But I think there's
really
a distinction
exciting.
you have to make here. And there's a distinction about prototyping and finalizing a design, and then there's manufacturing. and so if it's a one-off design, then from an additive standpoint, some things make complete sense and some things don't.
Exactly.
And if it's large-scale production and it's a relatively low-value part, if you will, then of course there's tried and true, molding techniques and subtractive processes that are far more efficient. So, unfortunately, it's not a one-size-fits-all. But I think if you had to bound the problem, if you put it on a Harvard Business Square 2x2 grid, and you looked at expense, production, value, high-value parts, large-scale production, high-value parts, low-scale production, then you can look at what manufacturing technique is possible. And then there's some that you can only do through an additive process. And of course, hopefully that's for something that's of extreme high value if it's only that one-off. But I think those are the engineering you got to bound the trade-offs.
Tim, maybe you can tell us a bit more, or again, from your bicycle design. What was the approach here to get a good design? What was at the end a good design for you?
The good design for the bike.
Yeah.
So very often it's the client who comes to us with a lot of requirements, and like she said, they don't have any knowledge on the design or engineering process. This is often what we have to teach them, to guide them through it. So a lot of our job is to teach them what we are doing and explain to them why we made this decision. Design is like making a lot of decisions again and again. So we have to guide them through it and tell to them what we are doing. And in the end, they understand why the design ends up this way. But most importantly, we show them why the design doesn't look another way. So we show them all of the ideas that we had that we didn't choose. And that makes that this design is the best one. That is like how I like to think about it. And I have to show them all of the ideas that we had that we didn't go for, that was not the design that we wanted to make, but we still show them to the client or to the customer or to anyone, because it's really important to be very sure that this design is how you want it to be.
John brought an important aspect, the aspect of cost of a part and the production of a part. What is the step when you're designing and talking about the different solutions you can offer? When is the point where you say, okay, and this will be the cost to produce it? Is it in the very first step, or is it like an iteration little step?
It changes every time, right?
Yeah.
Because
so
you have more ideas.
I would say, this really depends on the project. So within our company, we would like to save quite some budget to prototyping and to do the manufacturing, because it really helps with the design process. But in some cases, you also have to be really flexible with the budget, and then you have to make other decisions based on the budget as well sometimes. That is the case. But sometimes when the budget is not a limitation, you can really do a lot more amazing things. And that's what also happened. Like I showed before, one bike we 3D printed out of aluminum or aluminum composite. And the parts were welded together. And the whole frame and the handlebar and the seat post in total, it cost 20,000 euro a wand to print that. But it was really worth it because it fit the timeline. It was presented and here in Frankfurt at this event at the Eurobike. It's in July. So it was really worth it for this client. And also it was really the only way to do it. So it's both.
Mm-hmm. You wanted to add something?
No, but sometimes it can be very depressing when you have such a good idea and there's no money left for the good idea.
Yes.
So, yeah.
But again, for you, the question as well. When do you talk about the cost of a piece, cost per piece? When is it the right time to talk
Sometimes
about
the
that?
client comes to us and said, "This is the budget point."
From the very first
From the
beginning.
very first beginning,
per piece.
exactly. Yes,
Mm-hmm.
and yeah, you're doing research, then you do a concept, and sometimes you find new functions for the concept, and then sometimes everything changes because you have new numbers. You can erase another part for this part, and so the budget is really dynamic, I guess. So there's right now I couldn't say there's this one point where you tell the customer because it's talking and talking and yeah, it's really different, right?
What
I
about?
don't know.
It's a really important thing because I think for a designer, they have much more freedom to be creative
Yeah.
and to do what they want when there would be unlimited budget.
Of course.
That would be like the dream situation for a designer to design products in, but that's not the world we live in. So.
What about the knowledge about the different methods? That is the same thing for software as well.
Right.
So because different manufacturing methods have different limitations and different possibilities. How to include this?
Well, many software technologies now allow you to do cost buildups and do rough cost estimates based upon different manufacturing techniques. And there's plenty of solutions and tools out there that are marketplaces that you can go get cost estimates very quickly. Now, you may not get exact sort of pricing, but you're going to get ballpark pricing. And so I think that's the obligation of a designer early on. Of course, if you're building the Taj Mahal and they want just basic housing, well, that's a problem, right? So I think it's the job of the designer, one of the trade-offs, to understand what the cost ultimately could be and should be. But you've got to, that's why unit cost is important because you got to look at how you're amortizing the costs. If you're going to do injection molding, of course your cost per part's going to be very low, but you got to make sure you amortize the cost of the mold. And it could take longer to make that mold. And so what's your timeline? And these are the trade-offs. And the tools that are available today in the design solutions as well as partners allow for people to make those trade-offs a lot easier, actually. Because just like you can simulate the physical sort of part in terms of structural analysis, thermal analysis based on that 3D model, you can also start to do cost projections and schedule projections with all the components that are there. There are plenty of solutions that allow you to do that. And it really is incumbent upon early in the process to understand what are some of the parameters of that design and the target costs. Not just the target price for the product, but target costs.
Mm-hmm. Coming back to the maturity of the AM market as a whole, I wanted to get your opinion here. I have a slide for you. Terry Wallace was so kindly and gave this one to me. So it shows that there is a bit more than the half of the AM products are functional prototypes and end-user parts. So 56% on the right hand. And all the others are, educational, cosmetic models, fixtures, others, polymers, metal tooling parts. Is this for you the picture of a mature AM market from your perspective?
I think that's a little, I don't know if you have it, but if you double-clicked on that a little bit, I think when you look at end-use parts, if you take out the dental market, which is really the epitome, I'm talking about retainers in terms of like, for people who, instead of alternative to braces. If you take that out of there with Invisalign and the other players that are making that, my guess is that that number shrinks down pretty significantly, because I think it's probably inclusive of those end-use parts. That's a case where without additive and without good digital design tools, that would not exist. If you remove that, then I think it changes a little bit, and I would say we're mature as a market in the design and prototyping phase. And we're starting to see true end-use manufacturing cases starting to evolve. You're seeing it, for example, I know Stratasys, we've done some work where functional parts are actually being end-use manufactured for connectors and cables and precision electronics. Jigs and fixtures are actually being deployed, not as functional prototypes, but actually as manufacturing jigs for the shop floor. End-use parts is just starting. I'd say that's a nascent part of the market. So most of this is true. Take part of that baby blue pie and slide that down a little bit. And end-use manufactured parts, outside of some of those early areas, that's probably the nascent part of the market. The rest of it is starting to mature, and you can probably see it actually in the evolution of some of the additive manufacturing vendors and the products that they've built.
Is it not the case that designers should be more, practical oriented to get a bigger part of the cake as end user parts? Shouldn't be there more force in the business of the designing?
I think that's where it's going to, but we need a few years to do that. It's not like,
So I did a presentation earlier, but not everybody was here, I think. So we're doing some electric bicycle frames and handlebars and other parts where we use additive manufacturing in the final production of the bike, and also for the end consumer, the widening of bicycles that are printed, that are made using AM. But on this cake, I see a big potential, especially in the tooling, in the molds, and in the fix and jigs and fixtures, where now it's a quite small percentage, but I think especially there, you can see also over the next few years, taking more of the cake, I think.
Then coming from the task in widening the end user business to what are the problems the designers face? What are the challenges designers have that we cannot get much better into the business of AM parts?
Serial parts, so end-use
serial
parts. Yes,
yeah,
exactly. Yeah. There are a few. Like I said, always some. But most of the time you have to explaining. Then you have clients that have material certifications, force transmission, and they have to think about all that. And it's kind of hard to get from us designers from the idea to the construction part in the end. And I think the most important thing is we are kind of between two working generations, the traditional way and this new way. And we have to find a way through it. Exactly, because we also have some designers that never have experienced AM before or are never trained to use it.
So Tim, is it a question of generation? So if time moves on, we will see more and more?
Yeah, but also I think as a designer, it's important to meet the suppliers and to know which suppliers are out there where you can work with. Like 2 years ago, I was here at Formnext, and I met a company called Materialized. They are based in Belgium, and they had some electric bicycles in their booth, and that, we met them here and we exchanged business cards, and around a year later, we needed a bike which could be ridden, so it was strong enough. And even what they told me when I was visiting here is that this bike, it can be tested at the TUV to get a certification. So it's not only printed and can be wideable, but you also even can get it certified here in Germany. So that was like a really big eye-opener for me as a designer, but I do that all the time. I visit trade shows, talk with traditional manufacturers, but also here to talk with additive manufacturers. And for me, it's really important to know which options we have as a designer. It's a really important job. It's my responsibility to be the expert about this.
Exactly.
Yeah, and as manufacturers in the 3D printing world, we have, we have to ride down the curve of the cost per part of manufacturing. There's no question. I mean, industry's had basically 100 years of mass production to find ways to drive down costs of production. And I think that's going to be accelerated in the additive world, but we certainly have to go down in terms of cost per part. We had increased reliability, repeatability, and these are things that are being worked on and improved, I would say, with every new generation of machine that's coming out from all of the vendors.
Which industry sector do you think has most potential?
Well, I think large-scale manufacturing. Do I think we're going to be doing some of the largest parts? No. I think what we're going to be doing is small lot production runs where the investment in tooling is really expensive. I think that's the obvious sort of toehold to go into the market, as well as ones that have a varied sort of material sort of decision criteria where there's performant materials that people may want to make trade-offs. That's not so easy to do in traditional manufacturing sort of processes. So I think you've got to look at it, turning the vectors on the side that we want to attack from to do manufacturing. But I'm confident that long term, the additive will play a major role in manufacturing, as well as continued subtractive manufacturing processes, because they're critical too, and both from durability, provability, accessibility, and cost.
When we compare the topics we are discussing right now internationally, so when we're looking at Europe, at China, we have the partner country Australia this year here, US for sure. Where do you see differences, or where do you say, okay, that's the same because we have a globalized world and the production process is mainly globalized? I can buy it in China or I can buy it in US, so that makes no difference.
Well, that's a loaded question, especially in the US these days. I would say, I think there's I'll speak specifically about the US and I'll give a global view. From my perspective in the US, we have a learning curve to go back up and rebuild what I'd call the core of small, medium-sized business manufacturing. There's many shops that are there, but they have not invested along the digital transformation that I think they need to make to be competitive. So there's a huge initiative in the US government, as well as many manufacturing sort of areas and universities to kind of build up the core set in that small and medium-sized manufacturing businesses. And I think that's a consequence of a lot of the offshoring that we had over the years. Global manufacturing is not going to change. The economics may change relative to some of the political policies that are, and taxation policies and tariffs that may be applied, but there's global expertise in global manufacturing and global scale that's still critical and will be for many years. And I think that's a good thing, actually, personally. But in terms of additive manufacturing, yeah, sure. To the extent if we're going up that learning curve and there's alternative ways of doing manufacturing, I think you'll start to see skill build up in that area as well for longer term. As far as Australia and the rest of the world, there still will be globalization, may just not be at the same level it has been in the past. That's just my view.
You mentioned the initiatives from the government in US. Are they helpful? Do they accelerate the business?
I think there's a push to do it. I wouldn't say that they're completely there, but I think in the Infrastructure Act that Biden had done, there was a lot of, in Workplace for the Future, there was a bunch of studies done at the MIT Sloan School to actually look at automation and saying, don't think about it as a replacement. Think about it as the fact that we're going to need more workers. We have a demographics problem. So there was some money that was put aside there, and there's a push to try and create some funding to focus on small and medium-sized manufacturing. What happens now in terms of the political sort of winds of change, I don't know, but there was certainly a push that was initiated to go and do that.
Would we need some project or some funding in Europe as well?
Of course.
Which shape should that program have? Who should be funded, or on what terms?
That's quite a difficult question, because you have to find the places where you train people for AM, and then you have to go to the concerns maybe, and how can I say this in English?
say in German?
the Kompetenzzentren, for example.
Kompetenzzentren.
Competence centers,
Yeah.
exactly, and they spread out the word for new innovations.
But we have institutes like
Of course,
like
yes, we have.
Fraunhofer and
Exactly,
and so
but
on.
I think you have to put more effort into this because Germany has to learn a lot, and I think we have to compense a lot what the other countries may
it-
have. So
yeah.
we have to put money more in Forschung.
So it's educational, research, development.
Of course, yes, exactly.
Okay.
Also in schools.
Okay.
I don't know how many schools you know where there are 3D printers, but this is also one point that we have to do, show the next generation how we work in the future.
But it's not just a government initiative. There was a
No,
large,
of course not.
There was a large aerospace manufacturer that
Yeah.
did a. They trained. It's the second session they've done it, and each one had 5,000 students that were trained by MIT, focused on additive manufacturing, and they happen to use Onshape. I can't name the company, but that's 10,000 people that have been trained on additive manufacturing through collaboration with Onshape, this other company, and MIT. So things are happening to help basically move people up the, I'll call it the educational scale and knowledge scale in terms of additive.
But it's happening a few years too late
Sure,
sometimes.
but
yeah.
these things start and then they need to be rinsed and repeated, right? And that's
So we
that
are
will
all
happen.
here to spread the word out. Yeah.
Tim, what's your opinion in funding or in building up some programs, and how should they be shaped?
Well, for us, we are working on a project where we are doing research on how we can use additive manufacturing to make parts and frames of bicycles, especially. And I think the bicycle is a really nice project to be working on and to be learning on. So like maybe that inspired me to maybe work together. So the bicycle to be used as a product that everyone knows and everyone can ride and can test it, but to combine that with training and research as well. So we're already doing that even in the UK with wood assembly. The government is funding the project, but also the 3D additive manufacturing machines and all the tooling that is needed. So in the UK, they're also investing in it. And in the Netherlands, we're also working with some local suppliers as well that are working on this. So yeah, it's especially on the research, but also on really making a project which could potentially going to market as well. There's some really great examples of electric bicycles that have used additive manufacturing in the final production, not always successful, like some designs were too fragile and too weak, and customers were having problems with that. So it's really important as well to do the software simulations as well, and to do to make sure that it's really ready for market. So, but I think very soon you can see much more of that. I really believe that.
Let's a little bit skip the topic. I want to talk with you three guys about regulation. Is regulation for designers a problem, or is it a helpful aspect if you have a good and a clear regulation, or do you? We just wanted to talk about programs from the government. Maybe less regulation could be a good funding program as well. What is your perspective here?
What exact regulation do you mean?
So when you have products, you have strict regulated markets. For example, in medical. But these regulations can help to design design, because as a designer, okay, there are some limitations from the regulation side, and I have to work in these regulations. And in AM, we do not see so much regulations as, for example, in other manufacturing areas.
Yeah, but you have regulations everywhere. It's not like you said, but you also have. Sometimes you have millimeters where you have to find a shape around. In AM you have more free forms. So regulations are always nothing good for creativity, of course not. But we are used to regulations. We work around them sometimes, right?
Yeah, well, don't know if there's really needed to be regulations on the manufacturing of the product. But what I think is really great is that the suppliers in general are improving so much that they can make parts that follow all the structural regulations that a part needs to be sold into the market. And that's what I really like to see over the last 5 to 10 years. You see that they are really working on that. So that's really great. As a designer, it's more easy to go for that because we know that often maybe it's also responsibility of the supplier than the designer. So we work with suppliers who understand the regulations and they can guide us as well, give recommendations on the design and the materials and the process and the methods. So we work together with the supplier. They know the regulations and we know the product. Together we make suitable for consumers.
Mm-hmm. So could regulation be an opener for new markets or an accelerator to get into new markets?
My personal opinion is regulations should be where regulations need to be. I don't think we need to increase regulations. I think we need to remove a bunch of restrictions, if you will. But there are certain places, of course, as you point out in medical, that require, for obvious reasons, and aerospace. But other than that, I don't think regulations really should play a huge role in the initial parts of design and additive. I think, of course, on the recyclability and toxicity of materials, but that's already in place. And the thing I'm most excited about is materials development. It's been amazing the amount of new materials being introduced every day in the additive space, and that's going to add a ton of design flexibility for people that heretofore may not have been able to make a structural component appropriately or something that can deal with high temperatures and still be performant. And those materials are being developed every day. So that to me is incredibly exciting. I think unleashing the power of creativity for materials, the application of those materials, the design and simulation of those materials, I think that's an area that's we're going to see a lot of advancement and therefore usage of AM in terms of design of end-use products.
Okay, so not a helpful aspect here. But you mentioned different materials. How do you keep track on the different materials and the different machines as well? So you have the different spaces where you can create your products or future products. And maybe there is a machine who can give you a bit more production space. How do you know it? How do you keep track on these informations?
I think it's the reason we're all here today, because the industry changes so fast. You come here every year and you see new things, and it's like you said, John, the material, the wave of new materials, it's crazy. And this is exciting, really exciting for me when you go out, see all this stuff. And the clients rely to us to know about this. Mm-hmm. Yes, because we are the speakers on the outside. Right? And yeah, trade fairs, talk to people, ask specialists. I think the last thing you can do is stay at home and wait for something commercial to pop up.
Does your software support the users with information about material aspects?
There is. There are a lot of the vendors in the design space are trying to embrace material libraries that get updated pretty regularly.
Right, yeah.
I think if you just step back, I think what's interesting is this industry has been incredibly exciting and then kind of all of a sudden had a very, very tough period here. And I think that's natural in economics. There was just an oversupply of capital that was put into this market for startups, and with unrealistic expectations about how the market would grow. And there's a rationalization that's happening in the market. That's healthy. That's a good thing. And with that rationalization, you're going to see green shoots of new companies, and you're going to see the established people that survive that will prosper as well. And with that, there'll be a rationalization of where you can get information, routes to market, suppliers, service bureaus. That's a good thing. And so I'd say reach out to the different vendors, reach out to the suppliers themselves, and learn about some of the new materials, because it gives you design flexibility that you may not have had before. And that, to me, means that we're going to hopefully build products that better suit what the end users are actually looking for, and they're better performant, and they're more reliable, higher quality, et cetera.
Okay, thank you.
Can I add something?
Sure.
It's not only design flexibility, it's when you have some material that nobody thought of yet, you may have this one thing that's better than the other ones. So, yeah.
Yeah, you're right.
Yeah, with new functionalities brought with you. I remember I saw some years people said you cannot print silicon. And then the first, we went here around Formnext, and the first booth, yeah, we can print silicon.
Or houses.
Or houses, yeah. Yeah, I want to make a last question round for you. I'm not sure if it's an easy question, but last question would be for me: which is your biggest challenge that has to be solved to scale the market of additive manufacturing? What is this one problem you see that should be solved, and from whom?
That's a really broad question. So,
but what is
I know. I think for me personally, it's knowledge and staying up to date, because it's, yeah, like I said, it's very fast changing, and you have to talk to everyone, learn new things. But you don't have to do this only. You also have other stuff to do, like economics, and so knowledge and spreading the word. And I think maybe the industry will speak for itself, and you see it more growing and growing. And I think we are going to get there. Maybe faster than we think.
Okay.
Because sometimes you have people that don't know that they're holding 3D printed parts in their hands, like just like that. It's AM manufactured and they don't know about it. So, yeah.
What is the biggest challenge?
For me, it's the large-scale printing. So really, the bike frame is quite big. And ideally, you would print the whole frame as one piece. But there's so many different angles in there. So it's like a 5-axis printing robot that you could use. But it takes a lot of time. And the surface that they are currently making is not precise enough, and it's like quite rough. So a lot of finishing has to be done on the frame. So I really like to challenge the industry that I think in 5 or 10 years it will definitely be possible to print a whole bike frame relatively fast and affordable, and the quality is also good, and you can ride it and you can sell it as something that I would really like to see in the future. That is like one of my dreams. And then maybe one thing, like in my vision, it would be combined with AI. So each bike that is printed, each frame that is printed is completely unique. Like now I'm using a software called Viscom in the design process. And they have recently they launched a new tool that is where you can have the shape that you have a 2D shape, click on a button, and they make a 3D version out of that. So, and at the moment, AI is really bad at designing bicycles. It doesn't know how the chain should fit. AI doesn't understand it. So together with AI improving and additive manufacturing improving, I see a really cool future for the bicycle industry.
Okay, thank you. For you, the biggest challenge?
I think from an industry standpoint, to get into end-use manufacturing, which is where all the money is really spent by manufacturers, I say it's really about being able to drive reliability. It really is not one, but it's price and reliability, I think, are the most important things. We got to be able to get the price per part down to a point where it's competitive with some of the long-established techniques, and reliability. Not repeatability, not so much reliability. Repeatability from those end-use manufactured parts, and that will happen in scale over time. The question is which segments are opportunistic right now, where the price and repeatability can satisfy, and that'll expand.
And how do we get to this?
Well, it's already happening. It's happening.
So it's
evolutionary.
Continuously improvement in all aspects from the vendor side.
Yeah, and it's not. My guess is it's not going to be whole bike frames early on, right? It's going to be build volumes that are smaller, but there's literally thousands of components that are made every day, and manufactured techniques that can be done through additive versus that could be competitive. And it's finding those use cases and then it's rinse and repeating, expanding, changing materials, changing performance characteristics,
So is
changing
it
the design. Design can play a role in this because
Yeah.
instead of making one component or 5 components that go together and make a part, you can make it one component. And that's how it evolves.
But it's not the material side, it's a machinery side when we look at
Well,
cost.
remember, materials and machines go hand in hand, right? So
So it's both. Oh.
It's going to be both, but it's happening. It's happening.
Okay. Yeah, thank you very much. Thank you very much for being with us. Time runs fast. We are already at the end of our panel discussion. I hope you three will have a tremendous fair here the next 3 days, or today's day. This evening we will have pitch next here, so maybe you stay here. We have a very good presentations here still. Thank you very much, and the audience. Thank you very much for looking at us, for being with us, and here at the booth. I hope you have a good day. And now we have a short break until let's have a look until 2:15, and then we will continue here with our Pitch Next event.